Let's take a look at input-output tables for functions. So very simply, an input is something that you start with, an ingredient. You put it into a rule, it follows this rule or these guidelines, and from there you get a product or an output. And we actually see these in real life quite often. If you're baking something, you have ingredients like milk, eggs, and sugar. You put them into a bowl, you follow a recipe, you follow that rule, and from there you get a cake as a product. Your output is a cake. A vending machine has selections at a very specific price. You follow the rule, you put the exact amount of change in, and from there, your output, your product is a soda. Computers with keyboards, functions, clicks, processing, they all use input outputs. Things like economics, supply and demand, all of these are good examples of input and outputs. So what does that mean for math class? Well, an input and an output, very simply, is what you're starting with and what you get. Your input abides by this rule to lead to your output. You can use input-output tables to identify a rule to describe the relationship between an input and an output. You can also use input-output tables to create a set of input and output tables that follow, it's the wrong color, but that's okay, that follow a very specific rule. And just a reminder that for each rule, there's exactly one output for every input. There's one output for every input when following a specific rule. And this is what the table looks like. We'll get into independent and dependent variables in a later video. So let's look at some examples here. So imagine that you're given this input-output table, some inputs, but no outputs, and you're given this rule. Divide by 2, then add 1. You can take all of your inputs, apply this rule, and get a very specific number as an output. So for example, if I use 0, I could do 0, and it tells me, okay, I divide my input by 2, 0 divided by 2, and then I add 1. So 0 divided by 2 is 0, plus 1 is 1. So my output is 1. Same thing with 2. I do 2 divided by 2 plus 1. 2 divided by 2 is 1. 1 plus 1. So my output would be 2. 4. 4 divided by 2 plus 1. It's 2 plus 1. 3. 6. My input, I do my input divided by 2. I add 1. My output is 4. And lastly, 8. My input divided by 2 plus 1. That's my rule. 8 divided by 2 is 4 plus 1. My output is 5. So here you can see for each input, when I apply the very specific rule, I get a different and unique output each time. And this looks a lot like an X, Y table for coordinate pairs, but again, in a later video. So we were able to fill an input-output set of numbers table from this input-output table by following this specific rule. You could also be given a scenario where you have an input, an output, and you got to figure out, well, what is the rule? So if my input here is 2 and my output is 6, well, my rule could be a couple of things. I could just add 4 to my input because 2 plus 4 is 6. I could also multiply by 3, because 2 times 3 is 6. I could also add 1, then multiply by 2. Would that work? Let's see. Because that would be 2 plus 1 times 2, 3 times 2. Oh, that's 6. So in this case, our missing rule could really be any one of these answers. So to recap, input-output tables are found in everyday life. You can use these to identify a rule, to describe the relationship between an input and output. You can create a set of input and output inputs and outputs from a specific rule. And then just a reminder that for each rule, there's exactly one output for every input.